Hello everybody, I am NicoD. So in this video I'm gonna show you 5 tricks to use on Raspberry Pi OS. So the first one is install another desktop. The second is overclocking the CPU. The third is set the NVMe to PCIe Gen 3. The fourth is using Snap for additional software. And the last is how to boot from the NVMe. So I start with a clean installation of Raspberry Pi OS. So this desktop looks very dated. This is LXDE. It looks like Windows 95. I don't find it a nice desktop experience. So for that I'm gonna install the GNOME desktop. So first we need another display manager. So I'm going to install GDM3. So sudo apt install GDM3. When it asks you what default display manager you want, then select GDM3. And then to install the desktop we can do sudo apt install GNOME. If you want the XFCE4 desktop, just type sudo apt install XFCE4. For Cinnamon, type Cinnamon. But I'm not gonna do it like that this time, so I'm going to use taskcell. So it is already installed by default on this image. If it isn't installed, just do sudo apt install taskcell. And now sudo taskcell to open it. So here you see the desktops that it can install. So the GNOME desktop, XFCE, GNOME Flashback, KDE Plasma, Cinnamon, Mate, LXDE, LXQT, Web Server, SSH Server and Laptop. I am going to install the GNOME desktop. So I let it install and after that we reboot. So sudo reboot. And once rebooted we get greeted by this screen. So the screen reader is on. Let me turn that off. So once you click on your username, there is a button over here on the right bottom corner and there you can choose what desktop you want to boot into. So I'm going to boot into GNOME. And here we are. And again the screen reader is on. Let me turn that off first.
Screen reader off.
Now the initial setup. So here we are in GNOME. So I do not like this, the way Android is used. So for that I install GNOME Shell Extension Manager and GNOME Shell Extensions. And with that I can add an Applications button and a Places button. So let me open the GNOME Extension Manager. Here it is. Here I add application menu, places, status indicator. So here I've got my start menu and here my places. Then I go to browse and I search for resource monitor. You will not find it in popularity. So I have to go to downloads and there I find it near the bottom. Here it is, install. And as last I install Freon. This is to check my temperatures. So Freon doesn't work out of the box. So I first set up resource monitor 1 second. CPU I show the frequency. The disks I turn off. And network I only show WLAN because I'm using Wi-Fi. And LM Sensors isn't installed, so Freon doesn't work, so I install LM Sensors. Sudo apt install LM Sensors. And then I open the Shell Extension Manager again. Turn off Freon and I turn it back on again. So this is how I like my GNOME desktop. This is a lot better than the default Raspberry Pi OS desktop. So that is installing another desktop. So now let's overclock the CPU. So it is simple to do that. So we need to adjust the config.txt. So let me open terminal. And now we type sudo nano /boot /firmware /config.txt. So over voltage delta, so it would use a little bit more voltage. ARM frequency to 3000, so 3000 megahertz is 3 gigahertz. So mine can do 3 gigahertz without a problem. Some Raspberry Pi 5s will not be able to do that. So then lower it until it works well. And then GPU frequency, I can do 1100 megahertz. So 1.1 gigahertz. If it isn't stable for you, then go to 1000. So now to save this, we press Ctrl X. We type Y for yes and enter. And now this is saved, but before I will reboot, I will first do a 7-zip benchmark. So as you see, the decompression result is 12,600. And now let me install SuperTux cards. And let's do a SuperTux card benchmark. So I set it to 1080p. I turn off the music and I show the FPS. Single player, I choose Tux, the football and the grass fields. I always use this for my benchmarking of the GPU. It doesn't run great, but it is near playable. So it is about 15 or 16 frames per second. So now let's see how it does with the overclocks. So sudo reboot. And once it reboots, we do the 7-zip benchmark again. And now we have 15,400 instead of 12,600. So that is a nice CPU performance increase. And now let's try SuperTux card for the GPU. And here we have got 17 to 18 frames instead of 15 or 16. So we have got 2 frames more. And you do feel that. So it is worth it to overclock the Raspberry Pi 5, but do know it will consume a lot more. So mine consumes 3.5 watts more when it is overclocked than when it is at default clocks. It is also possible for some Raspberry Pis to clock a little bit higher. Jeff Geerling made a video about that on Pi Day. Overclock Raspberry Pi 5 to 3.14 GHz. That is more for advanced users, so I will not show that here. So now number 3, set the NVMe to PCIe Gen 3. So I've got an NVMe head for my Raspberry Pi 5. And by default it is PCIe Gen 2 1 lane. So let's do a benchmark with GNOME disks. If you don't have GNOME disks installed, then do sudo apt install gnome-disk-utility. So I select my NVMe, I click the settings button, I go to benchmark, set it to 100 megabytes. And as you see, I get about 440 megabytes a second read and 380 megabytes a second write. And here you see, with Freon you can also see the NVMe temperature, which is handy. So now let's set it to PCIe Gen 3, so we again do sudo nano/boot/firmware/config.txt. And there I add these 2 lines, so dt parameter PCIe x1, so 1 lane, dt parameter PCIe x1, gen equals 3, so that sets it to Gen 3. If you have problems, set it to Gen 2 or leave this away. And now when we reboot, we again do the benchmark. And now we have 860 megabytes a second reads and 470 megabytes a second writes. So that is a nice boost. The read performance is about double. So it is also worth to do that. So now on to number 4. And that is using Snap for additional software. Now you might say, NicoD, why would you use Snap on a Debian distro? Well, let me explain it. So Raspberry Pi OS is based on Debian Bookworm, and Debian Bookworm has a terrible apt repository, so tons of programs are non-functional and will never be fixed. So for example, Kdenlive doesn't work, or Blender doesn't work. So here I install Kdenlive, so sudo apt install Kdenlive, and when I try it, the video screen is green, it can't play videos, it doesn't work. So for that, Snap can be an alternative to find applications that do not work. You could build it yourself, but that would take a long time, and it isn't easy to do either for Kdenlive. So let's close this broken mess, and I will first uninstall it, so sudo apt remove Kdenlive. And now to install Snap, we do sudo apt install snapd. It is best to restart after you installed Snap. I didn't do that. So to search something we type Snap, search, and here Kdenlive. And it shows me it has got version 23.08.4. So to install it, snap install Kdenlive. And when that is done, to run it, we type snap run Kdenlive. And we try it again with the video. And this works. It doesn't perform great, but it is better than not having anything. And now as last, install this to the NVMe and boot from it. So first we need to open Raspberry config, because we need the latest bootloader. So we go to advanced options, there to bootloader version, there to latest. Now we need to reboot, but before doing that I will do something else, so I will not reboot now. So there is a bug. The first time that you open Chromium it doesn't work, so I will do that now before I reboot. So it doesn't work, now we will reboot and then Chromium will work. So now we are back, I open Chromium and I search for Raspberry Pi OS install Pi apps. And here the first website. So this line is what we need. So we paste that into our terminal. So this installs Pi apps. A very handy tool to install a lot of apps. Now to open it we type pi-apps. And there we search for Balena. And here it is. And I click install. And once it is installed, I search for Etcher. And here it is. And with this we can clone our SD cards to NVMe. So we select clone drive. So the first is our SD card. Select. And then select the target. So here is my NVMe. Yes, I am sure. And this will take some time. Once it is done, we shut down the system. So the cloning is done. So let me take out my SD card, press the boot button or the power button, and now let's see if it boots. My display turns on slowly because I've got my capture device. It is turning on, and here we go. So here we are booted on the NVMe. So let me open GNOME disks. So there is one issue, there is free space. So let me fix that. So we will install gparted. So sudo apt install gparted. Then open gparted. Then right click on the partition, select resize, drag this to the end of the partition, click resize and click the check mark, and that is done. So now let's open GNOME disks again, and as you see I am using the full size of my NVMe, and now let's benchmark this, and as you see 870 megabytes a second. That ain't too bad. For a Raspberry Pi, that is. So that will be it for today. I hope you learned something. This is a beginner video. I had to learn all these things too. So thank you all for watching. Please like this video, subscribe to my channel. See you later. Bye.